Hello, my name is Andrew Grant, and this is the first video in a small series where we will be looking at developing with C++ modules in a sort of real-world environment. I'm going to use Visual Studio 2022, the latest version as of mid-April 2025. This is simply because the toolchain is rather accommodating and particularly helpful. First off, let's make sure that we've got the modules capabilities installed in Visual Studio. Kick off the Visual Studio installer and click on Modify. Go to the Individual Components tab and pop Modules into the search box. Enable Modules and click Modify. Click Yes for the access permission and wait for the component to be installed. Once everything is completed, fire up Visual Studio and click on the Create New Project. Select Console App, making sure it's a C++ project you are creating. Give it a name. In our case, we'll go with Starting Modules, all one word, Pascal case. This project will be available in GitHub. Link will be in the description. Once the project's been created, click on the Show All Files to quite literally show all files. Then head down to the project properties. Make sure you're in all configurations, then set the C++ standard to the latest. Now click on the C/C++ tab and set the Scan Sources for Module Dependencies to Yes, click Apply and OK. Head over to the project in the Solution Explorer, right click and add a new folder, which we'll identify as Hello, a Pascal case. Into this newly created folder, add a module. Right click on the folder and select Add and then Module. We'll call the module Hello, in Pascal case, the same as the containing folder. We're using Pascal case simply because it sort of makes sense, and in the very helpful Microsoft pages related to C++ modules, they use Pascal case. Links are in the description. This is what you're presented with when you create a new module. Delete the export void myfunc statement and replace it with the code like that being shown, or even better, with your own code. Make sure you have an export module with the module identifier, an export-import stud statement. This ensures that you've got access to the standard library, and an export namespace, which in our case is going to use the module identifier, and a class for the identifier of hello to whom. If you want to have a quick look at the standard library module, place the cursor on the word stud and press F12, or right click and click on Go to Module Stud, and you can have appear at the standard library module. It's really quite fascinating and well worth a look. Within this newly created class, we'll have the private access area first, which, despite being in the public module interface, is still private, just like usual. With the public access, which as always is the bit you interact with. And just for memory, protected access functions exactly as protected access does. And just in case you're curious, here are the functions from the private access area of the class hello to whom. There's nothing sophisticated or magical about them. I've made them as simple and as direct as possible, just so we can see that they work as intended. And here is the constructor and the greetings function from the public access area. That's a module sorted, so now we'll head over to the main entry function. Delete the text already present and replace it with what you see on the screen. Let's do a quick examination of the elements of the main entry file. The import stud is for the functionality that may not be available from the exported stud statement in the hello module. If it's not required, the compiler just ignores this statement, so no great loss in compilation times. Then we import the module we just created. Think exactly like a hash include whatever.h file, and then we can use this in our application. Compile in both debug and release mode. Once compilation's done, pull up the terminal, navigate to the debug folder, and run the application. As you can see, modules are really quite good. They're not that different from traditional C++ coding, though you do have to think quite carefully when writing modules. But once you get into the swing of it, they can be quite pleasant to code up. Just for fun, let's rewrite the module to include a private partition. First, write the class in the traditional way. Then, below the exported namespace, tap in, all lowercase, module, space, colon, space, private, finishing the statement off with a semicolon. This partition as it's known, is completely private. It's not available to the outside world at all. Quick note to self, this capability is only possible in what is known as the primary module. It's not available in submodules. We'll come to submodules in another video. And now we'll fill out the definitions of the various functions and the constructor in the order they were declared, and in the exact same way we would do in a normal declaration file. As before, compile in both debug and release mode, pull up the terminal, navigate to the debug folder and run the application. Okay, I think we've covered the important parts of starting with C++ modules, utilizing Visual Studio as the development environment. Thanks for watching, and I'll see you in the next video.